Hi guys, we'll start discussing about cycle detection in an undirected graph. We already spoke about cycle detection in a directed graph using DFS and topological sort. Now we'll see various ways of cycle detection in an undirected graph. So there are three ways as mentioned here. One is using DFS and the second one is using BFS and the third one is using union find algorithm. So this video focuses only about DFS way and the steps of cycle detection using DFS are mentioned here. First thing is you start a normal DFS traversal on a graph. So while traversing, what you will do is you will just keep a visited set. So whenever you visit a vertex, what you do is you add that vertex to your visited set. Okay, and and as soon as you visit a vertex, what you do in a DFS traversal, you go or to the deepest level possible, right? You explore its neighbors. So while exploring its neighbors, there are three conditions to be checked. So if the neighbor is not visited, then what you can do is you can push it to visited set and then you can start exploring that neighbors. Okay, and if the vertex is already in visited set, then there are two conditions here. If the neighbor is its parent, if the neighbor is parent of the vertex, then ignore it. If the neighbor is not parent, then cycle exists. So don't worry too much about these points. We'll start detection of a cycle. Then these points will be more clear to you. Okay. Yeah, this is a sample undirected graph. Okay. Now, what you will do is, let's say I'll start traversing from 0. This is my starting vertex. Let's say this is my visited set. Initially, I did not visit anything, right? This would be empty. Now I start visiting vertices. I'll visit 0. When I visit 0, what I'll do is I'll add it to the visited set. Okay. Now, since I'm doing a DFS traversal, I can put these in the stack as well. Okay, I'll put 0 in the stack. Now, what are its neighbors? 1 is its neighbor. So, what I'll do is I'll go to 1. When I go to 1, it is not visited. Okay. Now, I'll make it visited. I'll add it to the visited set. Okay. Now, what are the neighbors of 1? 0 is the neighbor of 1 and 2 is the neighbor of 1 and 4 is the neighbor of 1. Let's say I want to go to 0. What is the condition of 0? Is it present in visited set? Yes, it is present in visited set. And if it is present in visited set, is 0 parent of 1? Yes, it is parent because it is an undirected graph, right? Why we have put this parent condition is, since it is an undirected graph, so 1 will become neighbor of 0, 0 will become neighbor of 1. So what we'll think is, if you don't put this parent condition, like here what I have done is, if it is in visited set and its parent, ignore it because now it is in visited set, 0 is in visited set, but this is not a cycle. Since it is an undirected graph, you can have bidirectional edges and you can't consider this bidirectional edge as a cycle. Okay, that is why we have put the parent condition. So whenever you encounter a visited vertex, see if it is its adjacent vertex or not. No, it is not its like here it is its adjacent vertex. This can't be a cycle. That's why you have added this condition. Whenever you encounter it, check whether it is adjacent or not. Since it is its parent and it is its adjacent vertex, you cannot visit it. Just ignore this one. Okay. Now I'll start exploring the another neighbor. So I might want to go and visit this 2. Okay, 2 is not visited. So I can do that. I can add 2 to the visited set and I can add 2 to the stack as well. I can start like exploring 2. Now from 2, what are all the neighbors that exist? 1 is one neighbor and 2 is one neighbor. 3 is one neighbor. From 2, can you go to 1? No. It is visited and it is its parent. So I should ignore it. Okay. From 2, what is the another vertex? 3. Is 3 in visited set? No. See, it is not in visited set, so I can visit it. I'll add 3 to the stack. Okay. Now I'll make this as a visited. I'll go to 3 now. From 3, what are all the adjacent vertices that are possible? 4 is the adjacent vertex that is possible, and 2. So I cannot go to 2 because 2 is its parent. I cannot go to 2, and this will give you a wrong answer if you assume that it's a cycle. So I'll go to 4. Is 4 in visited set? No. So I can easily, explore this. I'll go to 4 and I'll add it to stack as well. Okay. Now 4 is in visited set. From 4, what are all the neighbors? 1 is one neighbor and 3 is one neighbor. Now, what happened? 4, when you want to go to 3, see if it is in visited set or not. Yes, it is in visited set. Okay, it is in its visited set, and check whether it's parent or not. Yeah, you came from 3, you traversed from 3 to 4, so 3 is your parent. 3 is your parent. You came from 3, so you can ignore it. Now check about 1. 1 is in visited. Is 1 parent? No, you came from 3. 4's parent is 3, not 1. So you have visited a vertex which is not parent. So what you should do then, this is a condition for the cycle. So cycle exists here. So you might get confused that this is also, it's adjacent vertex. It can also be considered a parent. So here parent means when you are traversing the graph, from which node you have come to this path. So if you see here, when you came to 1, you came from 0, right? So which means it is your parent. 0 is your parent. You did not come from 2 to 1. You came from 0 here. That's why the vertex through which you came, that can be considered as a parent here. Okay. Now like whenever you came to 1, you did not go to 0 because you came from 0, and this will become your parent. Even when you are at 2, you did not visit 1 because you came from 1, and it will become your parent. So you got it right. So it's a simple logic here. You just do the DFS traversal. But the only condition is whenever you encounter a visited vertex, see whether it's your parent or not. If it is not your parent, then it means that it will exist here. And you might wonder that you're just considering the visited set here, which means that either a vertex is visited or not. Either a vertex will have 0 or 1 for its visited value. But in a directed graph, what you have done is we took 3 values for detection in a directed graph: 0, 1, 2. 0 means not visited, 1 is means visited and not yet processed, 2 means completed. Why you need 3 values for directed graph? You can, go just with the 1, right? Because in a directed graph, since it's it can be a single directional or direction also, it will give you the wrong answer. So in undirected graph, what happens is, if there is a connected component, this is a connected component. What is mean by connected component means, when like from any vertex, like I started traversal from 0, right? Even if I start traversal from 1 or 2 or 3 or 4, you will reach all its vertices. When you start from a vertex, you will reach all vertices in undirected graph, whereas that is not possible in directed graph, because there can be condition like 0 to 1. Okay, and it can be condition like 2. Now, if I start traversing from 0, what I'll get? I can traverse only 0 and 1. I cannot traverse 2. So, in one go, you cannot traverse all its vertices, okay? But in undirected graph, that is possible. So, that is also the reason why you consider only visited and not visited. There is no this completed logic here, because if it is a single connected, if it is a connected component, then 0 or 1 are enough to traverse complete graph. So this is also one of the reasons why you take 2 values here and 3 values in a directed graph. Okay. And if you talk about the time and space complexity here, you're traversing, you're doing, basically you're doing a DFS traversal, which means that order of V plus E is your time complexity. What have, because you are traversing all vertices and all edges. And coming to the space complexity, since you are using visited set, space complexity would be order of V. We are, excluding this recursion stack. So to summarize what we have discussed, you are basically doing a DFS traversal. But while doing a DFS traversal, if you encounter, if it is not visited, then you just keep on doing DFS. But if it is visited, there are two conditions. Please check if it is its parent or not. If it is its parent, ignore. If it is not its parent, then there exists a cycle. Simple, just 3 points. Yeah, thank you.